will need a high volume of oil. This is why I've chosen design 3, which has a favorable gear ratio, which is about more than 1, and the volume of oil needed, which is 11.15 liter. And now I've come to my final design. As you can see, this is my unidirectional gearbox, and the alternator is connected to the unidirectional gearbox using chain because of the distance. And the board and the wood board as a supporting structure for my device. And it's important to know the theory part, but to make it into a practice, we have to do the manufacturing. This is why I started my manufacturing since December last year. And this is the process that in my manufacturing, as you can see. Yeah, and this is the rack. Basically, I just bought the racks they use in the grill gate, and I just weld it together to make it 2 meters long. And you can see the side of the rack is a semi-rectangular shape, so that's why it can be guided by the roller. Because the rack is subjected to a different direction, different direction of wave hitting the rack. That's why the roller will hold the rack in position so that it doesn't move, so that it moves vertically up and down. And this is my unidirectional gearbox that I'm manufacturing with the help of the staff in the workshop, gear A, gear B, and the sprockets. And this is the table. The legs has to be sliding so that to lower down the center of gravity, so that the table can withstand a weight of the whole device, which is about 40 to 50 kilograms. And the board is attached to the rack by just using a few pieces of wood and boards. Yeah, and for the alternator, because the rotor is on the outer shell of the alternator, that's why the gear is attached to the alternator by using a few bolts. And the shaft here is fixed to the alternator holders here, so that the shaft doesn't move together when, with the rotor. I'm going to show you a video of the site testing that I've done for, yeah. And the right corner, bottom corner here, this is the reading of the voltmeter, and this is the reading of the current, the ammeter, which shows the current. And the right top corner shows the power curve, which is a product between the voltage and the current. And the video is edited so that you can see how the device works from different camera angles. It's not working. I'm sorry, I'm just going to show you here. It's interesting, isn't it? Therefore, now I've come to my conclusion for today, which I discovered that the ocean waves have the potential to be the next alternative energy source of the future. And throughout this process, I learned that even putting a simple theory into a practice is a very challenging task indeed. And the time management and the proper planning are very important to make sure the schedule are on time. And as we say, a goal is a dream with a deadline. So if we have a dream and we can achieve the dream within a certain deadline, it will become a goal. And this is the future works that I can think of to improve my device in the future. And first, I'm going to purchase a different permanent magnet alternator, provided that I have enough of funds. With the efficient permanent magnet alternator, we have a slow starting torque and robust and longer lifetime. And for the power takeoff systems, instead of using drag and pinion, I'll choose a hydraulic system or even linear generator. And in order to increase the power output of the device, I have multiple devices. And for the side, as you can see from the video, is located on top of the table. So instead of just placing on the table, I can choose to place on a fixed structure so that it can withstand the heat from the wave. And if you need any further information, you can always visit the official website of RUSEF, which can be shown in here, www.rusef.com. Yep. And thank you.
Any questions?
Yeah.
So how much power did you actually get out of your?
At its peak, it can reach about 400 watt actually.
Right.
Yeah.
And it's, I mean, the speed is changing, right? The speed of the...
Yeah, because the wave frequency and the wave amplitude is different. I mean, differs by time.
Even as one wave passes,
Yeah.
the speed of your gears is changing, right?
Yeah.
And the speed of the alternator changes. So what happens?
Yeah, as you can see from the video,
I couldn't really see that.
yeah, I know. It's a technical problem with the actually, I've tried somewhere else. It's working good. As you can see from the power curve, I'm just going to explain. It's just basically it's not a constant because of the frequency of the wave and amplitude. That's why the power curve is keep changing. It indicates the power output actually is keep changing. It's not constant.
So that 400 watts is the peak power?
Yeah, it's a peak power. That's why actually in the future, I'm thinking to charge it to storage energy such as a battery so that the power output will be constant and smooth. Yeah. Is there any questions?
So you must have a measure of efficiency though, right? So
Yeah.
do you have some sort of number that you can say how efficient you
Yeah.
Because you know the energy, you kind of know the energy input. You can.
Yeah, because I have the theoretical ocean waves, I can calculate it. Actually, because of the budget constraint, as I mentioned, budget constraint, the time limit, so the efficiency for the device is not really high. It's only about less than about 30%.
What would you do? What do you need to do to improve that? I mean, where's the major inefficiency?
Yeah, actually, because of the budget, the alternator that we bought is $600 itself, and it's not really a good alternator. If you use a really good alternator, like it costs about like $100 US, the starting torque is very low and it's very efficient. Yeah, that's one of the main concern.
Any other questions? Okay, thank you very much.